Hey team. Right, we're going to the last part of complex numbers. I'm afraid that I'm not in and it is save the best till last and all that. But obviously see questions that you have, please keep them. As I said, we've got plenty of time before the final assessment. And obviously I'll be back before, your March assessment. So, questions about this, you need to just take note of them and ask me, okay? I don't want you stressed about it. Because it's a wee bit different than what we've been doing. So obviously last week we were looking at De Moivre's theorem, which was used for integer powers. We're also going to look at it for rational powers, aka fractions. Now the issue with this is that they can ask this in a number of different ways, so I'm going to try and explain it in every single question how they can ask it in an exam. And obviously when we look at past paper questions, you will see what I mean. Okay, so first of all, basically what we're going to be doing is finding the roots of a complex number. Okay, so roots of them. So we're going to try and find the nth root. That means we should find so many roots, okay? So we're looking for the third root, for instance, there's 3 roots. Or you could also say that that is like a power of a third, for instance, in terms of the fraction. That means there's going to be 3 roots. So we can find all the roots by adding, basically. What we're doing each time is we're adding 2k pi to every single root. Okay, now k just depends on the number of roots. We start at 1, we'll start at 0, 1, 2, 3, for instance, or depending on how many roots we're going to have. We start at 0 and we go all the way up to basically until we get the correct number of roots. I do have a kind of general form of this. It's not given in your formula sheet. I'll explain it as we go through it. Now, as we spoke about before, the argument should always be between negative pi and pi. Now, this really only applies to final answers. So when I'm working through this, I'll show you what I mean. You actually do get the same answer if you don't, obviously, this, 2 pi is the same as 4 pi, like cos 2 pi is the same as cos of 4 pi. It doesn't need to be between pi and negative pi. Final answers do, yes. So if they ask in a certain way, I do expect you to do that. But for this sort of question, we don't actually have to do that in this sense. So what we've got here is it said, find the cube root of z when z is this, and they've given it to us in polar form. Now, there's other ways they can ask this question. So one of the ways they could ask you is they could ask you to solve z cubed equals 8 cos pi over 4 plus I sine pi over 4. Obviously, z to the power, of a third is the same as that. And that's what I'm going to be thinking about when I'm doing this. Okay, the first thing I'm going to do is I'm going to talk about this general form for this, okay? Now, the general form of this question, I tend to just apply it to the question. It's a bit messy if I don't actually apply it to the question I'm going to be doing. So the general form of this question would be z to the power of a third is... So we've got the number at the front, which is your r, 8 to the power of a third. No, Jesus. Cos of a third. So like De Moivre's theorem, remember, your power obviously goes in there. So when it was z squared, then we had the number at the front squared, cos of 2 pi, for instance. Not 2 pi, 2 theta, sorry. So our general form is, we're going to start with our theta. I'll put this in. Theta plus 2k pi. Now we're working in radians in this question. Plus I sine of a third. Theta plus 2k pi. Okay, so this is our general form for this question. Obviously putting the third in because it's a bit messy if I don't actually put the numbers in. So what we're doing each time is we're going to find our different roots. Now we're going to be looking for 3 roots because it's a power of a third. Oops. And we're going to be starting with k is 0, k is 1, and k is 2 to take us up to our 3 roots. So the first thing we're going to look at is when k is 0. Now, they quite often in an exam, what they'll do is they'll show it like this. So because we're looking for 3 roots, they'll call this 1. So this is the first root of z cubed in a way, because that's really what they're asking you to do is solve z cubed. And to get that is when k is 0. So think of it as being like the previous one. So if it's the first root, it's when k is 0. Second root, k is 1, and so on. So 8 to the power of a third is 2. What we've got is cos of a third. Theta in this question is pi over 4. Plus, now what we've got is k is 0. Obviously that second term is just going to be 0. So I'm not going to close off. plus I sine of a third pi over 4, which is 2. Cos of, obviously a third of that is pi over 12, plus I sine pi over 12. So that is your first root. Okay, second root, k is 1. So we're going to call this z2, 3. Again, the number at the front is always going to stay the same, so it's going to be 2. Just going back to that general form, cos of a third. What we're doing this time is our theta, pi over 4, plus 2k pi. So k is obviously 1 this time, so we're adding on 2 pi. Pi over 4 plus 2 pi. Now, pi over 4 plus 2 pi is obviously 9 pi over 4. So we've got a third of 9 pi over 4. Now, again, you can kind of do the fractions in a sense in your calculator, but what we've really got is a third of, I'll put that line in, let's just do it. Cos of a third. I know it's this issue because I've taken a whole space here, you may not have the space for it. So I'm just going to skip it actually. So that in there, quarter plus 2 is 9 over 4. A third of 9 over 4 is obviously 3 pi over 4. Okay, so that's your second root. Last root. Two cos of a third theta. So this time k is 2. So obviously this is changing each time. K is 2, going back to your general form. What we're really doing now is we're doing plus 4 pi. Now again, you could skip this bit and be like, oh, that's 17 pi. So we've got 2 cos. So obviously again, we've got 17 pi over 4. A quarter plus 4 pi is 17 pi over 4. Times that by a third. It's going to be 17 pi over 12. Now technically, that's obviously not between theta and not between pi, sorry, and negative pi. So we should be taking away 2 pi. I'm going to do it in this case, but there's certain questions depending on how they want you to leave the answer, and it ties them at exact values. You won't have to do this. I'll show you what I mean. So anyway, I'm going to take away 2 pi, and I'm going to get 2 cos of. Obviously, you're taking away minus 24, you're taking away 24. So, minus 7 pi over 12 plus I sine of minus 7 pi over 12. Now, when these quarter questions do tend to be in a calculator paper, so just use it for your fractions. So, those are your 3 roots. Now, there's different ways they can ask this question as well. Okay, so in this case, what they've done is they've given you the polar form of the complex number that they want you to get the roots